engineering. Looking forward to a wonderful session with all of you. Can you hear me? Am I audible?
Yes, sir.
Yes,
sir.
of course. Thank you.
Oh, okay. Thank you, sir. Shall we get started?
Sure, you can start. Sure, you can
Okay, thank you. I will share my screen. Please apologize for the background noise. I am staying very near to the National Highway. I'm currently based in Calicut. So, as this is a very tough time for people all around, lot of background noise will be there. Kindly forgive that. Let me share my screen. I hope the screen is visible right now.
Yes, sir.
Okay. We will get started with some of the essential points about Ethereum. Ethereum 2.0 is the roadmap. Is the roadmap on which the current Ethereum protocol is heading into. Ethereum 2.0 is not yet a reality, but it is in the process. Why I have given the caption as Ethereum 2.0 is this is the focus with which the entire Ethereum engineering ecosystem is working since the last 2 years. Ethereum, as you know, the protocol was launched in 2013-14. And what is Ethereum? Ethereum is world's first programmable blockchain. Blockchain, as all of you know, is a combination of a lot of things. You can't define blockchain as a single term. Like we can't say that it's just a data structure or it's just a collection of technologies. Ethereum is a new engineering ecosystem. Just like we talk about Java or any programming languages, Ethereum has become very wide. So as in the Ethereum, if I show you the starting point of Ethereum is always ethereum.org, the website. This is the website from where we all start our journey into Ethereum. It is a private internet. This is Ethereum is taking us to a new paradigm, a new internet ecosystem where there is privacy of people, privacy of enterprises, privacy of governments, privacy of all different stakeholders of internet will be respected. It's a peer-to-peer network, and it is designed to be censorship resistant in terms of every definition on censorship. Like it could be censorship on data, censorship on algorithms, censorship on applications, and all that sort. And at the same time, Ethereum is also proposing a new way of banking for everyone, an inclusive banking ecosystem, quite different from the contemporary banking ecosystem. Ethereum is proposing a new banking ecosystem. So before going into the detailed aspects of Ethereum, please let me show you a diagram which explains to you a comprehensive view of Ethereum engineering. Ethereum, you can call it Ethereum technology or Ethereum engineering. On the top, you can see compiler. Ethereum has let's start from the bottom up, because this is the way we interpret blockchain. There are two ways. When you look at the current internet, you can either interpret top down or bottom up. When you look bottom up, you can see Ethereum has an interface to physical data or cyber data. So any kind of cyber physical systems can be integrated to Ethereum. The blocks are the what you see as blocks are the sequence of data which are chained together by hash pointers. Hash pointers are nothing but the cryptographic hashes which are linking adjacent data. And Ethereum also has on the top of this block, what you see is a virtual machine to process this block of data. This is an interesting difference when you look at Ethereum and Bitcoin. Bitcoin doesn't have a virtual machine. On the contrary, Bitcoin uses a server process. The key differentiator between Ethereum and Bitcoin is Bitcoin doesn't have smart contract functionality in its original conceptualization or inception, but later on, Bitcoin also started supporting smart contracts. On the top of the smart contracts, you need an interpreter and compiler to explain the smart contracts. So it is very important to understand the difference between Ethereum and Bitcoin protocol, because Bitcoin was the first blockchain protocol where when you look at the bitcoin.org website, this is another website I recommend for anybody who is interested to study about the origin of the blockchain technology, bitcoin.org. You can get started with Bitcoin. It is important to read the white paper to understand Bitcoin. So my request is, all the teachers, if you are interested in delving deep into blockchain, it's good if you refer to the Bitcoin white paper from the site. Okay, so now we are heading back to Ethereum. What you see here is the way state is processed in Bitcoin and Ethereum. There is subtle difference in the way states are processed. State means the state of the state machine. I'm sure all of you are more familiar with the concepts of state machine than somebody from an industry like me. So here, the state machine is more probabilistic than deterministic. When you look at state machines, we generally categorize them into different kind of state machines: sequential state machines, parallel state machines, and sometimes we also, in the case of Ethereum, in the case of blockchains, two broad categorizations of state machines are state machine which uses UTXO data structure, and other state machine is state machines which make use of the state machines which make use of the replication, data replication and synchronization. Okay, so that's the introduction. What you see here in the state machines are what you see in the two different state machines are. In the first one, you are seeing, can you please give me a moment? Excuse me for the inconvenience. Okay, so back to the session. The state machines that we handle in Bitcoin and Ethereum, as you see here, you're directly transferring the value in the Bitcoin state machine. And when you look at the Ethereum state machine, you are doing a data transformation. That's the key difference between the two state machines. Okay, we can delve deeper into the state machine concepts. What you're seeing here in the state are the hash, the data in the form of hashes. So I hope all of you are familiar with cryptographic hashing. Cryptographic hashing is a technique used for obfuscating data and compressing the data so that they are efficiently transferred from one computer to another computer. This is the key benefit of state machines. State machines, I am sure all of you have studied about state machines. I'm sure all of you have studied about state machines in the case of Turing state machines, or from Alan Turing's concepts about state machines and Alonzo Church. They have their own concepts about state machines. I'm sure that is something all of you have covered in your classes. So now the key point I wanted to explain is the way state transition happens. We are now specifically talking about Ethereum state machine. This is a very important concept to understand when we deal with the Ethereum, because right now we are moving into a new paradigm where the computation will not be there are a lot of improvisations in Ethereum when we move from 1.0 to 2.0. That I will be explaining once you have a good comfort level on Ethereum engineering concepts. So some of the proposals are sharding of data, which is something you must have referred when you study about database designs. Sharding helps for scalability. Then the other concept is applying new kind of randomization using something known as verifiable delay functions, which is a cryptographic concept. The third important concept is incremental Merkle tree algorithm, or we are looking at a new kind of Merkle tree. Merkle tree, I'm sure you must have studied in the blockchain fundamentals class. And stateless Ethereum is a concept which is proposed will be stateless in the eventual implementation of Ethereum 2.0, which is one of the most latest upgrades on Ethereum. So that is stateless Ethereum is a very advanced concept which we will study once we have good comfort on the Ethereum fundamentals. So this is a simple representation of transactions in an Ethereum state machine. There is communication. So there is a state transition. What you're seeing is a state transition function. The arguments of state transition functions are the nonce. Nonce is a very negligible number which is used for triggering the state transition in Ethereum. Nonce, you must have studied, nonce has been used in Bitcoin for invoking a particular consensus algorithm called proof of work in Bitcoin. And there is a different kind of proof of work used in Ethereum. But those differences are very subtle. Okay. And other arguments are gas limit, gas price, the destination, the value of the economic value of this particular transaction, then 3 arguments to the digital signature, which is generated using elliptical curve based digital signature algorithm called ECDSA. I'm sure all of you have studied about elliptical curve cryptography and how we use how we trigger digital signature algorithms using cryptographic arguments or parameters V, R, and S. And finally, the most important element is the data that we feed into the Ethereum state machine. So Ethereum state machine is doing all this magic. Let us see a state transition diagram. I'm sure, I hope all of you remember how we studied about Ruth Horowitz criterion and how the state transition happens. What you see here is a state transition from S0 to S1 to S2, S3, S4, S5, and finally reaching a state known as S6. So as we understand, a valid signature for the transaction is the starting point. Otherwise, how would we trust the node which is initiating the transaction? Whether it's a, we should know, we shouldn't be able to verify it. This is because what we are doing is verifiable computation. All the computation that we do on Ethereum and all general purpose blockchains are verifiable computations, and what we use is verifiable data structures and verifiable log. This is very important concept when we study about a system like engineering system like Ethereum with a valid. So first, when you're moving from the initial state, you check the signature. If the signature is valid, the second validation is, does this particular node has enough balance to initiate the transaction? If it doesn't have enough balance, from S1 we are moving to S6. The other situation is S6 is the final state, or that is the halting state. Halting state, halting problems and halting state is something I'm sure we have studied when we studied about Turing state machine and Alonso-Church state machine. Okay, so if you have enough balance, now you are initializing a particular object known as gas. This is a computational object or a particular abstraction for the Ethereum state machine computation. If you have enough gas, enough balance, from this balance you are abstracting the balance into something known as gas. Why are we using gas? The concept of gas, there are a lot of ways in which we explain it. Some people say gas helps you to prevent infinite computation, infinite Turing machines on Ethereum. So you are avoiding a situation where you get into an infinite loop of computation, or a kind of logical or a programming, a kind of axiomatic error. But the simple explanation is, it is created to secure the Ethereum state machine and Ethereum computation to a great level. Once you are able to initialize gas, then the compilation happens, and then the transaction data structure is verified. If your transaction data structure is properly compiled by the Ethereum virtual machine, the transaction is approved or transaction is completed. If not, transaction fails. I can show you a simple example of a transaction from Ethereum online. Before show you how to reach here. This is called Remix Ethereum. If you search in Google or any other browser that you're using, you give remix.ethereum.org. It will take you to your Ethereum client. This is the integrated development environment for programming in Ethereum. There are a few more online environments available, like ETHFiddle. ETHFiddle is another tool. If you go to Ethereum website, you can see a lot of other tools which we can use. Developers home. Let me take you to developers home. So if you want to start experimenting with Ethereum, Remix is another tool. Another interesting tool is ETHBuild. ETH.build. This is more for the API engineers who work with Ethereum. Let's get started with the contract, because that is the crux of Ethereum engineering. Okay, so here I will show you contracts in Ethereum. Let's first see a very simple contract. We will get into this contract in detail after a few slides. What you generally do is you try to let me do a simple change. I'm trying to once I change it, I can compile it. So here I select the version. I can select different versions, but right now the most safest version ranges between 0.7 and 0.9. And the language, there are two different languages available, general purpose languages, Solidity and UL. And you can select different compilers. Ethereum has different compilers based on their different upgrades. There are a lot of hard forks and soft forks on Ethereum. So based on that, you can select whichever compiler you want. The latest one is Berlin. And after compilation, you can select where do you want to deploy it. So this is the basic environment of Ethereum. I will come back to this once we get into the smart contract part. If there are any questions, I can take them now, or I can take them after the session. Feel free to interrupt in case you have any important questions. So now let us get into another example transaction. This is an example of doing a blinded auction. Blinded auction is a very peculiar type of auction which can be executed as a smart contract for lotteries or different other systems, right? So we are starting with the state, initial condition. Initial state is ABB. No, actually we are starting from, we are starting from the, I could say we are starting from the, ABB. You're doing the bid, and the bid you can either execute with a particular timer, because you can see that it's a timer function, time locked function, and after you execute it, you can see once the execution is complete, you can go to the reveal option. You can reveal the result. If this is the normal situation, it will be finished, and then you can withdraw the value. We can withdraw the whatever you're staked into the auction, you can withdraw it. But if there is a hostile bid, or if there is an adversarial bid, the bid get cancelled. The other situation is, from the beginning itself, there is a hostile bid or an adversarial bid. This can be cancelled. So net, what we say is the auctions are either. So this highlights a point about the distributed ledgers. One of the key point is to highlight the fault tolerance of this system, the block Ethereum system. The main security or main reason why we use blockchains or blockchains like Ethereum is its fault tolerance. If you look at the last 5 to 6 years, there has been so many attacks on Ethereum, but despite all that, Ethereum protocol is moving further and further. It's still one of the most valued blockchain protocols in the world. That shows that this is fault tolerant. So we are creating a finite fault tolerant state machine. So what we have in Ethereum as a replicated state machine is a fault tolerant state machine. Okay, now let me go to the next slide. This slide talks about the details of the data structure in the state machine. So when you look at the state machine, you are seeing the hash pointer, and below the hash pointer, you are seeing the value of that particular transaction. So the header The hash is the address of the particular entry into the block. So the state of Ethereum at a particular point in time is the aggregate of all the transactions embedded in it. Some transactions would be a very simple transaction. For example, this shows that I have or somebody has an account with 1024 ETH. The second transaction is a smart contract transaction, which we will study in the next coming slides. Okay, so smart contract is the very important concept which we have to study. And here you see somebody is executing a smart contract. The contract logic is there. The interesting point is you can see the code. The code is stored on a database. That's the beauty of it. In the past, it was not very easy to store a logic on a database, executable logic, programmable logic. In the past, we had to use things like we used stored procedures, different kind of materialized views, if I am correct, and we use different kind of techniques to store code and execute them on a database. Ethereum has made this particular aspect very easy. So you can execute a contract, kind of economic contract or a logical contract or a legal contract or a regulatory contract. Any kind of contracts can be executed if you are able to convert them into a syntax which can be processed by Ethereum, just like what you have seen in the remix. Here, when you go to remix, you can see this is the language which it can easily interpret, right? So that's the difference. So there are two kind of accounts or accounts in Ethereum. One is the Ethereum Ethereum account. Another one is the smart contract. You are seeing one more smart contract, but the smart contract has consumed all the ETH, where the previous one has 5202 ETH. Here you have only 0 ETH. So you don't have any further ETH for the transaction. So right now, what is happening? This is the state. This is the state at time 0, and this is the state. This is the transaction you are doing from one address to another address, and then you are passing value 10 and data 2. So here you are seeing that 5202 is incremented to 5212, and the data you are passing is 2 Charlie, and you are also signing the transaction using elliptical curve digital signature algorithm. And finally, you can only the one, but only the transactions hashed intact, and the pointers remain the same. If you are not doing any change in if you are just appending the data, the block addresses won't change. I'm sure you must have seen the demo in the previous sessions on the blockchain fundamentals. Let me take you to the one interesting slide. This shows the details of the state machine, which will become more clear to you when you come to the Ethereum data structure slide. So here what you're seeing is a Ethereum blockchain store data and process data. As we know, it's a state machine. State machine has a collection of 3 Merkle tree. We call it Patricia Merkle tree. The Merkle tree, the basic Merkle tree used in the Bitcoin, is upgraded to a new type of tree. You can go to Wikipedia and search about it. It's called Patricia Merkle tree. There are articles about it. You can read about these articles, or you can come to Ethereum Wiki. Ethereum Wiki is a very good starting point for you to understand this data structure. Merkle Patricia tree, which is used in the Ethereum. I just paste the link here. You can refer it. Okay, what are you seeing here? Here, what you're seeing is there is a header. Header is like, so the header body structure of Ethereum is very similar to the the HTML or any other protocol which we use, like TCP/IP or any internet protocol that we use. It has a header and the body, right? So the state root will be there on the header. How is it generated? It is generated from the world state trie. World state is something you must have heard when you studied about Hyperledger. Here we keep a different data structure. World state is stored in a different type of data structure in Hyperledger. Here it's a trie. Trie is the data structure. Okay, so you have, how do you start with it? You have three type of, as per the color code, you can see there are three type of trees. One is the account tree, second is the state tree, third is the receipt tree. So there is a kind of mixing of trees happening here. You're mixing the leaf, the node tree with the, so you're mixing the leaf tree with the branch tree and the extension tree. There are three kind of tree. When it forms a, finally it's all aggregated into hash. As what you
whether
see
this tree is available in that particular page, whether this tree from where,
sorry sir, I didn't get that
also, you are showing this data structure, no? Whether this data structure is available in that
yes,
particular page, in the URL that you have pasted in the chat box.
I'm sorry sir, I don't think it is available there. I can send you the link. It is available on Stack Overflow.
Okay, fine. Okay, thank you.
And I will be also sharing this presentation to you, sir.
Okay, thank you.
Sure. Okay. So this particular data structure is very important because, but one thing is there, when we move to Ethereum 2.0, this data structure will go through some small changes, because I will tell you, it's called vertical trie in Ethereum 2.0, which I will be giving I am not sure if I will get time to, I think it's vertical. Ethereum 2 is called, I will explain that part tomorrow. It's called vertical tree. Yeah, I will explain that in the when we get, if I'm able to cover it, I will cover it with you. Otherwise, I will give you the reference to read. So what you're seeing here is, this is the abstraction. On the right side top, we are seeing simplified world state. This is the same way, even in Hyperledger, you will see there is a subtle difference between Hyperledger and Ethereum. In Hyperledger, we have two kind of data entries, key value and key value. So one is a basic array, another one is an associative array. These two forms of data entry is possible in the ledger of Hyperledger. But here, if you see, it is more uniform here. And that is the reason why it is easy to write smart contracts in Ethereum compared to Hyperledger or any other tools. But very complex data contracts, you can use Hyperledger and Corda, like they have digital asset modeling language. Here, what you're seeing here is final, the parent is called root. This particular this is the final, this is the root of the Merkle tree. So the root of the Merkle tree has an extension. So you can, there is some other concept which I have to mention. It is called a reverse Polish notation, which you must have studied in reverse Polish notation.
Sir,
Polish
if
notation and
sir, if you take a simple example and explain, I think the data structure will be more clear. For example, suppose person A is transferring say $5 to person B. So how a block is created and how that block is represented here. If such a connection comes,
yeah, definitely.
Things will become more clear, I think.
Yes, sir, definitely. I will show you how the blocks are. Let me first show you what happens when you are doing a transaction, and then it will be easier for you to understand. So here,
Yes.
imagine, first I will show you a local blockchain in my local machine. This is a very small blockchain. This is a very lightweight Ethereum. I can do a heavyweight Ethereum, but that one takes around 8 GB memory minimum, and it also, that is the initial memory, and when it is running continuously it can take up to 25 to 30 GB. So I am running, this is my lightweight machine, so I am running this machine for, if you have a machine I can definitely run it. Is there any machine available where I can run this, sir? Probably I can, if you can give me a machine I can show it tomorrow, but otherwise I will try to show it in tomorrow's session. So this is a very basic Ethereum blockchain. You have a set of accounts, just like a bank. We have accounts. So in this account, either we can hold money like balance Ethereum, or we can do a smart contract transaction. The best tool that I can suggest is, I would request all of you to install something called Ganache. Ganache client software installation. If you can install this on your machine, I'll give you the link. This is coming from Truffle Suite. This you can install in Mac, Windows, and Linux, all the three. I'll give the link here. This will give you an experience where you can connect a particular transaction and you can execute it. But I can show you one other way. The way is using something called MetaMask. MetaMask is a client which will connect you to different blockchain environments. Okay, I hope you can see my screen. This is the account, my account in a test environment. You test means pre-production environment of Ethereum. There are 4 environments. One is Ropsten, Coherent, Rinkeby, and Goril. Out of this, Goril is a Ethereum 2.0 environment. Ropsten is the by default environment where you have proof of work consensus. Coherent has proof of authority, if I am correct. Rinkeby also has proof of work, I guess. And then there are a lot of other testnet. Even if Cochin University wants, Cochin University can also create your own Ethereum test environment. You can link this test environment with the Remix. Remix is the integrated development environment. For example, here I am trying the Web3 provider. When I am giving Web3 provider, initially, if I am giving my local environment, it will try to link to my local environment. So right now it is connected to my local environment. Deploy the contract called storage contract. So I think there is some connectivity issue. That's why it's throwing me an error. I'll try another environment online. Then you will understand how the deployment happens. So this is an example. I'm not sure if you can see the screen. Are you able to see this, sir?
Yes, sir.
Okay. So this is the example where I executed a particular smart contract. Smart contract is not, the term smart contract may sound a bit confusing. It is actually, you can call it chain code, or you can call it like a persistent script. Chain code is a very good title, because chain code means a code that is running on a chain. Or you can call it persistent script, because it's not a script, it's a code. So Hyperledger has used it, but people sometimes get confused. Chain code is at the moment we use chain code for indicating the smart contract written on Hyperledger. And the smart contracts that we write on Ethereum are known as smart contracts, or the code written on Ethereum are called as smart contract. Code written and deployed on Hyperledger are called chain code. And the code written on Corda are known as contract. Code written in Solana is also known as contract. So the nomenclature may sound a little different. Let's see what happens when you are deploying a block. Here I came here. You can see that it has deployed a block. So let's see what happens. Initially, it is listening. This particular server, this is not exactly a server, this is a client. The Ethereum test RPC client is using remote procedure call. That's why it's called RPC. And it is using JSON RPC. Right? JSON, you can use different kind of RPC. At the moment, or Ethereum 1 uses JSON RPC, and it is listening. It is looking for getting the blocks. So it is continuously polling, or it is continuously listening at the port 8545, and then it is looking for two things: whether it's a signed transaction, whether you have enough balance. If you have enough balance, then it will load all the accounts, and then it will look at the version of the block to make sure it's a valid block. If it is not a proper version, it will reject the block. The client has the discretion to reject or approve. That is the power of blockchain. It is not a silent spectator or an observer. It has the power to reject the incoming data. That's the security of, so we can say it is a very active client, not a passive client, right? And then it's not listening, getting anything, it is continuously listening. Then finally, what happens is, yeah, there is a data coming in. The Ethereum node has sent a transaction to the client, the another node. So what you're seeing here is the Ethereum JS is the library, which is this is the library which has implemented test RPC, and it is calling the command line interface CLI which is written in Node.js, and this is the particular. So what you're seeing here is it is compiling. It is actually processing all the information. So if you want to read it in detail, you can read it. What you see here it is calling all the environment variables initially. So it's bootstrapping. After bootstrapping, it is reading the header information in the binary format. Once it is decrypted, deciphered, decompiled, it is able to process the binary information, parsing. So there is parsing going on. It is parsing for the data. It is only parsing the data, and then there are some memory allocation happening. Dynamic calls and static calls are there, and then it is loading the runtime. Once it is loading the runtime, it is verifying the information. And what you see here is this is a stack-based virtual machine. That is a very important differentiation from Java and other programming languages. Ethereum uses stack-based virtual machine, which uses reverse polish notation, RPL, which is more secure compared to the registry-based virtual machine and the Polish notation used in other virtual machines. So if there are questions, and then what you see here is now it is compiling, it is translating whatever we have written in the high-level Solidity program into an intermediary language called Ethereum Op Code, which I can show you here. Deployed contract. Ask me if you have any questions. Let me show you the opcode. What you're seeing here is the transactions result, transactions hash value, where you are deploying it, and the amount of gas that you have used for this particular computation. This is the total gas available, which we have set here. And this is the gas which is used for computation. And then this is the hash. And this is the transaction log. Let me open it. I think my machine has become a little slow. Okay, that is not interpretable. Log is. Yeah, it's in the binary format. I will show you the opcode shortly. Ethereum. Let me show you the Ethereum opcode from the yellow paper. This is another important paper all of us should read. It's called Ethereum Yellow Paper. I'll give the link here. It's a little bit technically demanding, but it's worth good read. If you are planning to do research on Ethereum, understanding the yellow paper is very, very important, equally important like reading the white paper. Ethereum Opcode. Yeah, I'll show you the Ethereum opcode list. Yeah, this is the interesting example. As you see here, just like any other compiler, like 8086 or 8085, Ethereum also has a set of opcode for stopping or halting the Turing machine and adding. So every high-level instruction is converted into the for example, when you are if I am able to show you one code, it will be easier for you to understand. Yeah, before that, let me show you. Yeah, this is an example. This is the example. This shows the entire transaction record. This is the JSON file, which shows which gives you the complete detail of what happened in this particular. So when you executed this smart contract, or what you're seeing is this is the account which has done it, and this is the time at which the transaction is done. Then this is the address to the abstract binary interface. This is an very important term you should know when you are doing a particular transaction on Ethereum. This is the name of the smart contract, and this is the binary binary format on the binary value of the entire transaction, and this shows what are the key functions in it. So there is only one constructor. This has a one constructor. So by default, there will be one constructor from one account, and the ABI address input it is actually showing what are the variables that you have passed as an argument. So you passed an argument by the name num, which is of the type u in 256. So there could be two type of integers we can use in Ethereum, signed and unsigned. So this is an unsigned integer. So normal variable, normal transactions like any number, normal data types are all handled with unsigned values. But if you're dealing with so sometimes you're dealing with a negative balance, or you're dealing with debt, or any other financial value which can go negative, right? Then for all those purposes, we use signed integer. And here there is another variable which is stored. So let's understand this code. If you want to understand this code, we should understand. So the parent object is contract, just like class in C++, right? In C++ or Java, right? Contract is the highermost variable, and pragma is similar to the hash include that we use in C, right? Or other so this is like importing a particular library. You are importing the Solidity language libraries. So the first function is store, second is retrieve. So you are storing a value, data, into you're storing a value into blockchain. That's what you're doing with the store, passing a particular number argument of the integer type, and this is a public function. You can add more public pure function. There are certain cases in which you handle pure. So basically you can make the functions mutable or immutable. If you want to make them immutable, you give pure. If you want to make them mutable, you give other declaration. And then we can also have runtime modifications on the function. So retrieve is you're retrieving the value. So you store the value, and then you're doing a computation here, and then you're retrieving the value from the blockchain. That is what this function is doing. So here what you're seeing is, so even if you don't mention it, this is a immutable function. That's why the mutability is view. It's a read-only function. So there is one store and retrieve. And the other condition is you have to explicitly make the function payable. If you are dealing with financial data, or you're dealing with some financial transaction, you have to make it a payable function. But you have to be very, very careful when you're dealing with the payable arguments. I mean, payable functions. Okay, so let me, here you're seeing you're loading the account before deployment. What are you doing? Let me modify it once again. If you're modifying, it will be redeployed. So I am incrementing the number. Just a very simple change. This is where I select the gas. And if I want to give any specific value, I can give it here. You can't give more than that. So if you want to give a value like this, There is another network which you can use with Ethereum. It's called IPFS. If you publish it, it will add more gas fee. You can load an already deployed contract also. That's possible. Oh, okay.
Can we consider the concept of gas as fuel, very analogous to fuel? Like when you drive a car, we we
Yes, sir.
load it with say 1,000 rupees of petrol and then drive. If the concept is analogous,
Yes, sir. We can say it is analogous because if you look at, if you are looking at a car which is running with a particular
example?
gasoline fuel.
Can you take an example for a smart contract with two customers, and can you explain how this concept is working there?
Yes, yes. So one example could be you are trying to run a lottery, or let's take a simple auction. There are 10 users who want to participate in an auction. When there are 10 users are there, they are all joining. So for example, when you're starting the auction, they all of them have to, there are two ways you can do it. One is open auction, another is closed auction. If it is let's take the case of a closed auction where everyone has to give their name before, but one of them want to disrupt it on purpose. So what they can do is, even if they don't have enough money to win the auction, if they continue to obstruct it, if there is no gas limit, they can do it. Then adversarial user, if they have enough computational power. Imagine I am a user with a farm of server farm. I have a lot of computational power. Maybe I am running a quantum computer, or I am running a very powerful supercomputer. Like sometimes we are nowadays hearing people are using nuclear submarines for mining blockchain. No, not submarines, nuclear power stations. They have amazing, very huge, powerful computers. If they are trying to, they don't want to win it, but if they want to do a denial of service, or they want to just obstruct the auction, they can do it if there is no gas, the gas limit. And that is equally possible in the case of an open auction. Does it answer your question, sir?
No, it is not clear. I think you have to explain once more, or take another example.
Okay, okay. Another example could be the case in which you are going to a bank to open an account, and you already you don't have an interest in doing any transaction in the bank. You just want to delay the process. Like you just want to delay the process by which a lot of people are waiting in the queue. If you want to create a bad experience for the bank, you can. Yes, sir. Does it answer your question, sir?
Yes, I understood the scenario, but I would like to understand how this, what is the significance of this gas in a smart contract? For that, I want an example.
Sir, gas is in an abstraction of your transaction value. I can't show you the details of the code because that will take a lot of time.
No code. It's
the
not
code in which
code is not needed. Only take this example itself, bank account example. In that, what is that concept of gas? For example, in an account related with the bank account, how you can exemplify?
Yeah. So the cost for the computation, that is known as gas. The cost to the computation. So the cost for running the computation on that Turing machine is indicated by gas. So, sir, it is related to the concept of a Turing machine. When you have a Turing machine, there is a particular effort required to, move the computation. Like, you can look at the Turing machine itself, right? We have leaves or pages, right? The computation is like moving pages in a Turing machine. So the effort required for the computer to do it is here paid in terms of an object in a ledger. So this particular value that it's a like just like Barbara Liskov mentions it in the consensus. So she mentions in the account abstraction. This is abstracting the cost of computation. So it's like an abstract object of the cost of computation.
Okay, fine. Suppose one customer A is transferring $10 to another customer B. So it is a typical transaction, isn't it? Customer A is transferring $10 to customer B. So in that case, can we say that this much number of gas units is needed for computation power of that transaction? Is it like that?
Yes, sir, you can say that way because see, it's not only two people, it's not only two people who are part of the network in Ethereum. Even if you and me are doing a transaction, all other are part of the network. So the entire network is computing on for us. That's how it happens in Ethereum. That's why it's a multi-party computation system. So when sir and myself, we both want to do a transaction, like I want to transfer some money to you, or you want to do some transfer to me. You are proposing that as a block into the blockchain. So when that block is proposed, when your block is proposed, you and me are there. We know that you have initiated it. It comes to the common ledger. So when it comes to the ledger, it will have a particular cost. So for example, you are transferring 10 rupees. 10 rupees you are doing. So
computation power is needed.
That computation power which is indicative. You say when you are doing that process, what you indicate as the cost of computation is the value everyone will see. So the network then decide, should we support this transaction or should we commit this transaction? So then it's a majority rule. Then it's a decision by the majority if we need to allow this transaction. Those are called as the normally we call them minor in the case of Ethereum 1.0, but when we are in Ethereum 2.0, it's a different scenario. They are called as validators. Validators are people who are minimum 32 Ethereum staked into it. That they are like investors. They are not like simple miner. They are already invested 32 ETH of their wealth into the system, which is almost equal to close to 25 lakhs. So those are the people who will decide whether, sir, your transaction is approved into the system. So the majority of them have to approve. If it is not approved, when they approve, they will look at a lot of things. In the case of Ethereum 1.0, it was easier. But in now Ethereum 2.0, it will be more tougher scrutiny. So when it is a tougher scrutiny, after their validation, the block is processed and entered into the ledger. Only then the money will be transferred from your account to my account, sir. That's the so it is becoming more secure with Ethereum 2.0, but with more security, the experience will be a little bit affected because people will have to weight, and there are a lot of criteria. If you are a validator, even validators has to be running the node all the time. If the node is not running for 1 year, then they will be slashed. You will lose your validator authority. And if you do any adversarial or hostile or malicious behavior, then also it will be slashed. So and you should not do any kind of misbehavior like nothing at stake attack. There are a lot of ways in which you can be a Byzantine node. If any way you become a Byzantine node or a malicious node or a hostile node, or your server crashes frequently, you will be penalized. That is the situation in Ethereum 2.0. I hope I could answer that question, sir.
Yes, almost. Now, as the class progresses, more clarity will come.
Okay, sir. Sure. Thank you.
If we get such a real life examples and concept is clear, then when we see the technicalities, it will be more clear. Now it is almost, we are getting more clarity. Yeah.
Understand, sir. Understand. Yeah, I initially planned this as a more technical session. That's why I include practical examples. But yes, I can give examples as
there. Yeah.
Okay, sir. Thank you. And what I am right now, hope you can see my screen. So let me get back to the presentation slides. So we are still on the 10th slide. I would like to explain a few more things here. So this is like 3 type of Merkle trees which are getting aggregated, and then the entry is added to the key value pair, the kind of array. It's like a you can say it's a associative array or indexed array, where transaction the value from each so you can say you have 3 type of ledgers or 3 tables which are getting aggregated together. Now we are getting into the concept called smart contract, which we have seen in detail now. There are 2 type of objects which can exist on Ethereum. First type of object is known as externally owned account. The second type of object is contract. Both of them have 2 things in common: nonce and balance. The account state is the wrapper object for the nonce value, balance value, and in the case of contract, you have additional 2 hashes: the memory hash and the code hash. The memory of the, as the Sudeep sir asked, the cost of computation is calculated using the correlation of both of them, storage and code. The hash of the code will indicate the total computational effort. But sometimes, even if your code is small length, it will be using very advanced data types, like you may be using strings, or you may be using enumerators or struct. The code may be small, but the computational effort required to process them will be more. That is why we are correlating storage and code. And there is another interesting point we have to note. The externally owned account is controlled by private key. So under no circumstances we should disclose the private key. I was showing you the account, right? So this is the private key. This is the private key. If you have a account, this private key should not be disclosed to anybody under any circumstance. And this mnemonic is another thing. This should also be never disclosed to anybody. If you disclose your mnemonic, that's it. Your account is finished. Anybody can hack it. So the storage location is mentioned here. So this is something like a hardware wallet. So this is the test RPC is functioning as a wallet, where we know normal wallet. No, in normal wallet we don't have this facility, but the blockchain users, especially public blockchain users, have the hardware wallets and the hard wallets and the software wallets. There are a lot of wallets. Even though I shown you MetaMask, better wallets like Taurus. Taurus wallet is there. Taurus wallet, which is more safe. So I recommend using Taurus or Wallet Connect. Wallet Connect. Then there are other wallets possible. So Wallet Connect. This is a very safe wallet which you can initialize with an email address, and they have better cryptographic security. I think even MetaMask is working further to secure them more. So this is MetaMask, right? MetaMask is more accessed by people because it has a better. It was the first one to come into the stage, and a lot of the user base is good. The developer ecosystem is bigger, but Wallet Connect and Taurus are also coming up well. There are hardware wallets there, like Tether, Ledger Nano X, Ledger Nano X and S, but it is not very safe to buy them online because you don't know who has uploaded it. So there are a lot of tricky situations when you deal with them, which I can answer if you have specific questions. So there is a difference between externally owned account and contract account. Contract contain the Ethereum virtual machine code. Contract is controlled by that is the difference. And external owned account cannot contain an EVM code. This is the main difference. So this is explained by this diagram. Externally owned accounts contain the transactions, and then transactions, you can do transfer, just like Sudeep sir mentioned. You can do transactions, and then it is run as an internal transaction or an external transaction. You can do either transaction, or you can do multi-signature based transactions. That's where you have a transaction inside a transaction. So you can also relate what you studied earlier, state machine transitions, and what happens when you are executing a transaction. You are calling the transaction from a browser, from a browser page or a web page or a web application. It comes through HTTPS or HTTP, and then it comes to JSON RPC API system like Web3, or different kind of API systems are there. Web3 is the most popular among them. And then there could be offline and on-chain transactions. That's the important thing we should understand when we study about blockchain. An example could be when you're doing an auction, you don't want...
I don't know that.
When you're doing an auction, you don't want to store all the photos and all the details of the participants in an auction in the ledger. If you don't want to store them, you can store them in a auxiliary or a offline database. You can use any secure database, be it BitchainDB or CouchDB or LevelDB or MongoDB, whichever one you trust, whichever one is most secure, you can use it. And only the on-chain transaction need to be stored on the ledger. So for example, the account balance is the only one which we want to use for doing the auction. That is the only thing you should store on the chain. Every other information, because in the case of Ethereum, every computation, every storage, every computation has a cost associated with it. So we have to be as economical as possible. Okay, so now this particular diagram shows the paradigm of smart contracts. the better. This is an automated way to execute a code, so we can eliminate manual error, because there is so much manual security issues with manual transactions in the banks and financial services domain. Not only banks, even in healthcare. If you're losing your healthcare information, there's huge cost associated with it. So to avoid manual error, we can use smart contracts, and then you can use it as a data replication system in terms of when you're dealing with data sets like maybe genetic data, or you're dealing with information about the vehicles, or you're dealing with information about your digital identity. All this can be backed up into blockchain, because blockchain has, if you've created a really scalable blockchain, it can store the information until eternity. That is the beauty of it. And then the other advantages, it is the paradigm where the code gets a sanctity. Code, for example, you can run a court on blockchain. There are protocols like OpenLaw. It's something I just want. It's a open court running on blockchain. You can write real-world contracts on this. So here, if you come here, there are a lot of sample contracts that you can see here. Getting started. So it has its own rule engine, but the key thing that you should know is the OpenLaw beginner's guide. If you come here and so let me try to show you. I'm sorry, I think basically what you can do is you come here. If you want to create an NDA, you can simply create an NDA. This NDA will be stored inside a blockchain ledger, but there is a cost associated with it if you want to deploy it to the Ethereum mainnet. If you are doing a pilot, you don't have a cost associated with it. You can add company logo. You can do very, very advanced contracts in OpenLaw. Okay, so that's the example I wanted to mention. Importantly, you can also run a bank on blockchain. There are a lot of protocols which are doing open banking. Even in India, there is a project called Bank Chain that is bringing in a lot of banks together on a blockchain. They are currently trying it on Hyperledger, I believe. But you can also do the similar thing. A lot of banks in India have already piloted blockchain. Banks like ICICI Bank and Federal Bank and lot of others have already tried to do the KYC process on blockchain. And the advantage is you're removing intermediaries and you are able to execute transactions autonomously and without needing a heavy hardware like Intel SGX hardware. You must be knowing it. Intel, it's a trusted execution environment. Before blockchain was, before the popularity of blockchain, a lot of secure computation was done in trusted execution environment. Even today, there are projects where there are hybrids where both Ethereum, the hybrid of blockchain and trusted execution environments are done. But if it is a very secure blockchain, like a very large network like Ethereum, Bitcoin, or others, you don't need a trusted execution environment like Intel SGX. Right now, you have already seen the contracts. Here I am showing a token. Token contracts have completely revolutionized the world of blockchain, because now show you OpenSea. That is like an example of art projects on blockchain, OpenSea and CryptoKitties. Let me show you both of them. They are very popular. This is OpenSea. This is a place where you can upload your artwork, and people can come and purchase them. You can, if you're a painter, if you're an artist, you can upload your artwork here. So you come here and click on create. Then it will ask you to sign into your wallet. Right now I have only test account. I'm connecting my wallet. I've logged in. You can see profile. I can create a collection. So when I'm creating a collection, I can give an image. So okay, it's asking me to sign. Okay, let me try. Diagrams, screen. Okay, imagine I want to upload this design. I uploaded this design. If I am uploading, okay. Imagine I'm just uploading this design. I'll just give the title Oliver Twist. Just want to give Oliver Twist. Imagine, and so percentage fee is 0.02. Here I have to give my address. So after giving it, I can mention, do you want Ethereum or Polygon? Polygon is a project worth mentioning. This is then Ethereum's client and a bridge. It's an Ethereum layer 2 project. So, we should be proud that Polygon is a project from India, and this has really expanded the Ethereum ecosystem. And so, yeah, after giving all, then if you give the wallet details, it will, let me try to copy a wallet address. Okay, I'm just giving this wallet address. I can create my account. So I've created my collection. So this is the way you use OpenSea. Once you have collection, in that collection you can curate, you can select whichever art forms you like. One of the first token project, most popular, one of the most popular initial project is known as CryptoKitties. CryptoKitty allows us to buy they allow us to buy digital cats using Ethereum. Let's say I'm just selecting. So it's asking again me to sign it. This is one of the major security feature introduced in almost all of them, because elliptical curve cryptography at the moment is very safe, because it's more secure than RSA. That's the reason the digital signing is included in almost all the systems, Ethereum based systems. So here you are seeing there are different kind of kitties. So yeah, this is a fast kitty. This another one is, you can see, browse lot of kitties. You can see them, you can breed them when you're breeding. So it's a kind of gamified experience. Could you please give me a moment? Sir, can I get one moment? I'm getting a call repeatedly.
Sure, we will wait.
Thank you. Sorry for the inconvenience. I'm not sure if this was easy to understand, the CryptoKitty and the OpenSea. I will give the project links. You can browse them and see them. This is a concept known as tokens. This is a emerging business model. So in the near future, this will be more accessible to everyone. So basically, we can tokenize any kind of digital transformation of our internet that's happening through all these platforms. I hope that much is clear. If you have any questions, please feel free to ask. Digital business models became reality thanks to Ethereum ecosystem. Because Ethereum is something created by technologists for technologists. New kind of digital business models are coming because a lot of entrepreneurs, dropouts, they're all because it's very easy to start the experience. Writing code, testing code, and connecting to the blockchain. There are plenty of materials available on Ethereum.org, or if you go to YouTube, there are amazing number of digital channels. DAP University, Eat the Blocks. Eat the Blocks is another one. Then Berkeley, University of Berkeley, they have very good material. UC Berkeley. These are very good materials on Ethereum. DAP University. And I will also give link to one other. There are a lot of good articles by Consensus. Consensus is the for-profit venture of Ethereum Foundation. They also have created reading materials. Okay, so back to the session. Now I hope you can see the screen. I would like to show you how the interact with a blockchain. Just when you've seen the OpenSea, you could see that you are interacting to a code which is executed. a code which is executed and which is live on Ethereum. Let me show you another tool called Etherscan. Etherscan is a very important tool for you to see live smart contracts. Etherscan, that will be okay. Etherscan.io. Yeah, this is the Ethereum Block Explorer. Here you can see live transactions. What you see here, you can filters. You can see websites running on Ethereum. That's very interesting. You can see websites running. So, for example, you can see if I give Vitalik is the founder of Ethereum. We can see if there are no websites. Okay. Satoshi. Let's see if any Satoshi website is there. There is no website with Satoshi. That's okay. So I am just putting all filters. So here you can see latest blocks and transaction. Let's click on latest block. This block has, so you can say from the beginning of the block, what is its position in the block tree? Okay, I will show you another visualization shortly. That's called transaction street, blockchain transaction street. That will make it more clear. Street. Yeah, this will be more accessible to you. You can understand what is the scale of. Okay, while it loads, I will show you what is there. So this is a block which is executed 1 minute ago. It contains 68 transactions and 24 internal transactions. Let's click on, and then it is mined by one particular user. And this is the reward for mining this block. This is the reward given to the miners who are entering this block. Then uncle is the orphan block. Is there any uncle? And then the mining difficulty shows what was the cost of its computation. This is the aggregate difficulty of the Ethereum blockchain system. Gas used, you can see this is a gas used. It is actually a gas optimized transaction. That's why it's showing. It is only using the 36% of the actual gas it would have cost. So a lot of products are there in Ethereum now which are optimizing the gas cost of computation. This is the total limit. And then you can see if it is having a token burning. If for burning, what is the amount spent? You can see transaction hash, parent hash, the previous hash. You can see that it uses SHA-3 also. It is not using SHA-2. SHA-3 is supposed to be very, very secure. It could be SHA-3 uses a different algorithm from Lovegrover. Okay, and then it is the Merkle root, state root, and this is the nodes. Now let's see what are the transactions inside this. By the time it loads, let's see if it has come here. This is the diagram. I hope this is a visualization of how this, each house represents a type of transaction. So people are coming from houses, and each bus represents a future block. First bus leaves when a block is found. And then a coin name, when you click on a coin, you can change the street. So let's see, this is a house. So this is the house. So transaction grouping is something known as blockchain analytics, which was initially introduced in Ethereum by Google. Google has used their BigQuery system to analyze the entire Ethereum. And then now I think even Splunk is doing the same with their big data analytics. So this is the house of Tether, and this is the community one. Let's see. So okay, this is Axie Infinity. So there are different lot of this is a game known as Axie Infinity. So all the major transaction, all the MetaMask transactions, we have seen MetaMask now. That is the wallet which we have used. So all the transactions coming from MetaMask, you can see here. So all of them, which are confirmed, which are in the queue, which are pending, you can see all of them here. And this is MakerDAO. MakerDAO is a stable coin. It's a kind of a coin which its value is pegged to US dollars. That's the MakerDAO. It's a kind of decentralized autonomous organization. Then this is Shiba Swap. This is another small project, but it has become really huge in the last few years. Then there is Rarible, I guess. Rarible is a non-fungible token for artists, and so for creating and selling digital collectibles. And this is Compound. Compound is a project for doing compound interest-based lending on Ethereum. And then, so let's see, this is a block. This is a block which will be confirmed in 35 seconds. Let's see, this block will be confirmed in 11 seconds. And if you come down, you can see, so these are all, this will be confirmed in 2 minutes. So this is what happens in real time. This is showing Ethereum and this is showing Bitcoin. As you see, Bitcoin, the queue is so big and it is very, because the block time in Ethereum is more. It takes 10 minutes. That's why all are waiting in the queue. If you see here, now you can see that there are two lines, high fee line and low fee line. Low fee line is so huge in Ethereum. But you can see Bitcoin, the number of people are very less. I mean, compared to Ethereum, it's not very less. Bitcoin also is Bitcoin is still the biggest network, but in terms of the transactions, Ethereum has overtaken Bitcoin to an extent in some matrices. So there are 3,717 transactions pending in Bitcoin, whereas in Ethereum it is 75,000. So that shows the capacity with which blockchain projects have grown. This is Chainlink. Chainlink is an Oracle system on Ethereum. Oracle means bringing physical data feed into digital blockchains. And this is Aave, a lending protocol. Non-custodial means there is no centralized custodian for approving the loans. It's a kind of money market. It's very similar to Compound. It offers both the lending and borrowing. You can lend and borrow cryptocurrencies. This protocol is known as Aave protocol. You tokenize the deposits as tokens and they accrue interest in real time. This is the attraction. And so it's not like you have to wait for months and weeks. And this project is known as 0x. It's a permissionless protocol allowing people to exchange value. And this is CryptoKitty. CryptoKitty, we can see that not many transactions are happening now, but again, it was one of the largest projects when it started. And this is Curve Finance. Curve is a kind of exchange for trading between stable coins. Curve Finance. There are also plenty of transaction in this, but waiting time is there. Okay, let me get back to the Etherscan. So here you are seeing that every block contains so many transactions. Some of them are plain. If you see this transaction, this is Okay, so claim means you are claiming the ownership of an asset. That is why it's called claim. Transfer is an example of a transfer of money transaction, or it could be a transfer of token. Then when you do an exchange between two different kind of cryptocurrencies through Ethereum, it's a, you can also do matching. These are related to cryptocurrency exchanges, which are not currently approved in India. I mean, decentralized exchanges are not approved, but centralized exchanges are operating in India. So it's a like kind of multiple type of transactions. You can have withdrawal, approval. If you can want to approve, somebody has created a certificate, education certificate on blockchain. You can approve it through a particular smart contract. If you want to transfer one student from one college to another college, if you want that to be an immutable transaction, you can do it through blockchain. If you want multiple a student, that can be done as a multi-signature transaction. If you want to give a gift or a award or scholarship for a student, you can do it as a wrapper transaction. So different type of transactions are possible pretty much in Ethereum. This is how it happens on the back end, or this is how the technology works. You have a front-end JavaScript library. From this library, you talk to you talk to the interface of a smart contract. I'm sure all of you are familiar with the concept of interfaces when you studied about Java and other programming languages. So the smart contract is running on a blockchain can be exposed as a JavaScript object. And from that JavaScript object, here we use a library called Web3.js. When you use Web3, is the kind of way in which you can interact with a deployed contract. When you get an approve, so it's an authenticated access to a smart contract. Then you talk to the contract, which is running on an Ethereum node live. As you have seen the test RPC, the moment you deploy a smart contract, it is running as an object inside the system. Okay, is there any question till now? Okay, otherwise I will continue. Okay, so this is the node where the contract, if you are directly trying to access the, so Web3.js, Web3 JavaScript library is a system by which Ethereum exposes their contract, but you can access the Ethereum smart contract from a Raspberry Pi or a drone or any other system if you have enough computation power. How do you do that is you create your own extension of the Web3.js or your own JavaScript library, or you can write it in Python or any other language of your choice. It depends on, if you write in low-level languages, the performance will be good. If you write in high-level languages, interpreted languages like Python, you have to understand there is a performance trade-off. So, but if you use C++ or Rust, it will be easier. Or you can also use WebAssembly, which is a new paradigm of computing. So, using these library of your choice, you interact with a Ethereum node, and you get your access verified, and then you call the contract, and then you execute the contract. It could be, if you want, you can do a private Ethereum network. For example, nowadays enterprises are using private permission network of Ethereum. It's called Enterprise Ethereum. There is a name to it. It's called Ethereum Pantheon. Now Ethereum and Hyperledger have partnered together, and after this partnership, now it is known as Hyperledger, Besu and Hyperledger. There is a new name to it. Okay, So, but if you look at the Ethereum node for production, it could be, you can use the Go language version called Geth, which is the most popular one. You can also use PyEthereum, that is used by projects dealing with machine learning or big data or other industries like energy and electronics. And there is another known as CPP Ethereum, the C++ version. Combining to all of them, if you want, you can create a hybrid network of 4, minimum there should be 4 node as per the crash, to make sure it is Byzantine fault tolerant and crash fault tolerant. So when you have this many network members, you can create your own secure network. Okay. There is a more detailed schematic between Web3 and Ethereum. What happens between Web3.js and Ethereum? So when you have interaction from Web3 with Ethereum, you can see that initially what happens is the block is created and the block is approved and the contract is deployed. Once it is done, you get the abstract binary interface, which we called as ABI. So ABI contains all the information about the transaction. You have to, in your JavaScript, you have to include the approved account details and the data. And then you access, you initialize an object of a wallet. For example, if you're using MetaMask, you can initialize and instantiate the MetaMask wallet object. If you're using Taurus, Wallet Connect, Coinbase wallet, or any other wallet, you have to initialize and instantiate that wallet object. And then you are exposing the API through Web3.js. So using Web3.js, you can contact the executed contract through remote calls. When you're calling, that is what you're seeing here. When you're calling, you're seeing this remote call. Remote call will come to a transaction manager of Web3, and it will talk to the transaction in the client. You get the details. But if you want to initiate a transaction, even that is possible. That's why we call it Web3. Read, write, execute. All the 3 of them is possible from Web3.js into Ethereum. So this is like Ethereum is envisioning a future of internet where there are transactions happening from you can read data, write data, and execute data. That's why we call blockchain systems as the true contenders for Web3. Okay. So the next topic is one of the most important topic when you want to become Ethereum developer, Ethereum smart contract developer. The smart contracts, the design patterns for the smart contracts. So can we continue in tomorrow's session? Because otherwise there'll be break in this concept. Hello, teachers, are you able to hear me?
Yes, sir.
So next is a smart contract design patterns, which it is better if we take it on a single session. Otherwise, that concept you may not be able to follow it.
Okay, sir. Then
is it okay if we do it continue tomorrow?
Yes, sir. That is solidity programming.
It is, solidity programming best practices.
Okay, sir. Then we can continue.
We call them design patterns.
Okay, then we can continue it on tomorrow.
For me to deploy Ethereum for you?
Sir, pardon me?
Then it would be useful for, is it possible for, you can get a machine, a server machine for me to deploy Ethereum, if that can be used for your future purposes, if required.
That means storage is required not above 8 GB, 25 GB.
Yeah, you will need the storage in the future. Otherwise, you can destroy it after doing it tomorrow.
So no such machines are available.
But no problem, teacher. Then I will try to connect from my other machine.
Okay.
Otherwise, I will continue with the smart contract development related sessions.
Okay, sir. Okay.
Is there any other question, teacher? Or if you have, if you can consolidate questions.
Sir, I have a question.
Hello.
Sir, I have a question.
Yes, teacher.
So, can we do a transaction to a blockchain network from our mobile device? This Web3.js, can we develop it in a mobile device and do the transaction from mobile device?
Yes, teacher. It's definitely possible. Sorry, I did not mention it. You can do it from mobile devices. You can do it from web applications, cloud, and you can even do it from social networks. It's all possible, but you have to create a relevant, you have to make sure the security is in place, because mobile applications, it's not easy to secure them as much as web applications. So because you're dealing with financial transaction, it's recommended to ensure security for the client, the mobile device from which you are doing the transaction, because we are storing the financial information on the mobile device. Mobile devices are more prone to attack web applications most of the times. But technically it is possible, teacher.
Okay, thank you. So when we are doing it other than this cryptocurrency, for example, for any other, we are creating a private network in Ethereum for any other applications. So when we are using a mobile device for doing the transaction, so it's a data transaction, not any crypto. Either we are not transacting. There's a data transaction. So in that case, authenticity of this data we'll get the authenticity. We're using a mobile device for this data transaction.
It's a very good question, teacher. It's better to use a verified storage device. I mean, storage system like IPFS, along with the private network, when you are doing a data-centric transaction. For example, or you have to use oracles, but oracles are prone to attack. So the best approach would be, imagine you want to do a birth certificate storage or education certificate storage transaction on Ethereum. It's not recommended to store the entire certificate on blockchain, because it's very, especially in Ethereum, heavy object, or like a PDF file. If it is a 1 MB PDF file, but if you're doing even when you're doing a private network, you can't remove the gas, because that's written into the protocol. Okay, so but it's an abstract value only. In the case of a private network, that will be an abstract value. But if you store more and more heavy object, it will impact the performance. It will impact the performance of the Ethereum. So imagine initially you create the blockchain of the block size, minimum block size amount around 1 GB, right? Then the block creation time in Ethereum will be affected. It will become slow. So if it becomes slow, the performance will be affected. So better to store heavy objects on an auxiliary storage system like IPFS or BigChain DB. IPFS is considered to be most safe. There is another system called Filecoin. Filecoin gives you better control over the storage. But even when you use Filecoin, you don't need to use the cryptocurrency part. You can completely disregard it. Imagine you are not using cryptocurrency. You are using it only for storage. You can link the object that you store on the IPFS or Filecoin through hash pointer. So what you do, you generate a hash. IPFS, you address the content using
so that means
hash
is it called the off-chain and on-chain data?
Exactly, teacher. That's off-chain storage on IPFS, on-chain storage on Ethereum.
Ethereum.
And they are linked together. The off-chain data is linked to the on-chain contract.
So this IPFS, is it also acting as a node in this network for storage?
That's right. Yeah. IPFS also is a decentralized structure, and it's having multiple nodes. It's better you use a cluster of 4 IPFS nodes, and you should do something like pinning the data to persist the data on IPFS. It's called pinning data on IPFS. I have done a reference project like this. I can share with you the source code.
Oh, okay. Huh?
Thank you, teacher. That was a very good question because that's one of the first which we did on Ethereum and IPFS. Storing data. You can use it for certificates and mark sheets. Whatever you want to keep it for a long time, and which you want to be transparent and trustable for the academic community. You can use blockchain this way, and it is completely open source. It's very secure, but at the same time, the cost, there is no cost, license fee or license cost for it.
Okay, thank you, sir.
You're welcome, teacher. Is there any other question? I hope today's session was useful for all of you teachers. If you have any questions offline, kindly share them with the teacher, Raki ma'am, and others. You can, if you would like to ask questions, you can connect with me on Telegram or Twitter. I'm available as Gokul Alex on Telegram. And Twitter, I'm available on Gokul Gaze. So please feel free to share any other questions, or you can email me the questions. I will share the email address after tomorrow's session. Thank you so much for your valuable time. I sincerely hope this session was useful to all of you till now. If there is any, if I can improve any part of my session, please share your feedbacks as well.
Okay, sure, sir.
Thank you all.
Okay, thank you very much for your time, sir.
Pleasure. Thank you all. Bye-bye. See you tomorrow.
Okay, thank you, sir.
Thank you so much for the session, sir.